Okay. All right. So our circadian rhythm is our internal body clock, our internal biological clock. All right. And basically, what that means is that our body does certain things at certain times of the day. For instance, have you ever noticed like you fall asleep and you might just have like a light blanket on, and then you wake up at like 4 o'clock in the morning and you're like cold as shit? Okay, even though it's the same temperature in your room that it was before. Anybody ever notice that? And you got to get a heavier blanket middle of the night. Yeah, and then you put on the heavier blanket, you feel better, and then you wake up in the morning. If you're able to wake up naturally, you wake up in the morning and you're sweating like you have too many layers on now. Okay, that's because part of our circadian rhythm is body temperature. Our body temperature, right, goes down in the evening. All right, we hit our highest body temperature at about 7 o'clock at night, and then it slowly goes down from there with hitting our lowest body temperature at about 4 o'clock in the morning. And then it raises again the closer we get to morning. Okay. So part of our circadian rhythm is our body clock or is our body temperature. Does anybody have an idea why might our body temperature drop? There's an evolutionary reason for this. Why might our body temperature drop when we are asleep? Yeah. Okay, it's to conserve energy. All right. Lower body temperature, we burn less calories when we have a lower body temperature. If you think about like animals that hibernate, can like they lower their body temperature by a lot so that they don't burn as much fat while they are hibernating. I bet like for most of you all, you have to go to the bathroom at around the same time every morning. Okay, you wake up and then maybe an hour and a half after waking up, you got to go to the bathroom. All right, it's because that digestion slows down throughout the night. So, you know, um, and basically our bowel movements stop around 10 o'clock at night, and then they get going again in the morning. So once digestion gets going again, then you got to go to the bathroom. Um, Most of y'all are probably the most alert around 10, 11 o'clock in the morning. And then does anybody in here like take a nap every day, like pretty much every day after school? Even if it's just like a quick nap. Abigail, you do. Okay. Anybody else take a nap like pretty much every day after school? Yeah, Biffy, yep. Yeah. It's because we naturally get tired around that time. Around 1 to 3 o'clock in the afternoon, we kind of crash a little bit. And then we kind of wake back up a little bit later in the afternoon. But all of these things are controlled. The release of melatonin. What's melatonin? Anybody know? All right, yeah. Melatonin helps you sleep. Okay, your brain naturally produces it. Um, you know, now that we're around, um, like back before we had artificial light, people would go to sleep at 8:30 at night because that's when it got dark. All right, now that we have artificial light, it's kind of screwed up our sleep cycle a little bit. And because our brain starts to naturally produce melatonin as it gets darker, we're not having that experience anymore. And so it is, so a lot of us are having a harder time falling asleep earlier. All right. So, anybody have any questions about circadian rhythm? Now, all of our circadian rhythms are slightly different. And one of the things is, all right, are we more productive? Are we more awake in the morning or in the evening? So what I want for you to do real quick is I want you to take this survey, and it's just going to tell you if you are more of a morning person or more of an evening person, right? Or if you're just in between. Okay, so go ahead and take this. It should only take you a couple minutes to do. Okay, and once you find out, maybe like put it in the chat just to see. Yeah, Sarah, that's where I was too. I was directly in the middle. Okay, anybody else done? Put it in the chat. All right, so while you all are finishing that up, okay, all right, why do we need sleep? Well, for one thing, it protects us, not just from disease and whatnot, okay, but from, if you think about back in the day when there weren't lights, right? We needed to be asleep at night because if we weren't, if we were out wandering around, we might get like eaten by a saber-toothed tiger. Okay, so by sleeping, all right, it's an automatic protection. Helps us recuperate. All right, we all know when we're sick, the thing that we need the most of is sleep. Helps us improve cognitive functioning. They've found that a 20 to 45 minute nap can improve cognitive functioning for at least 6 hours. That a 20 to 45 minute nap can help us think clearer for 6 hours. One thing that I actually just learned, and I'd seen this before, but I didn't know exactly what the research was. Have you all heard about drinking a cup of coffee like 20 minutes before taking a nap? No, I had heard about coffee naps before, but I've never done one. Apparently, what that does is the caffeine doesn't have enough time to like really wake you up. But what it does is when you take the nap with having caffeine, the caffeine blocks adenosine, which is a neurotransmitter that kind of gives us like the groggy feeling. And so the caffeine blocks it so you wake up without having that groggy feeling. So pretty cool. Helps improve memory. All right. A lot of, for those of you that like pull all nighters studying for tests, actually the better thing to do is to study for a while and then go to sleep. All right. Because if it's kind of on your mind, your brain will help form those memories while you are sleeping. I had many dreams about what I had been studying in college. Helps us grow, especially for you all who are, you know, growing boys and girls right now. And then it helps us cope emotionally. You all know, like, if you're upset, like, one of the best things to do is just go to sleep. All right, sleep on it and generally wake up feeling better. All right, how much sleep do we need? Newborns, how much sleep do you think newborns need? If you have a guess, just put it in the chat. 16 hours, 18 to 20, 14. Okay, yep. Newborns need about 18 hours of sleep. All right, they're like greyhounds. How about little kids? How much do you think they need? Yeah, little kids need about 10 to 12 hours. And if they don't get it, they are nightmares. How about you all? How much sleep should you all be getting per night? 8 to 10. Yep. Y'all need about 9 hours of sleep per night, which is why it is so incredibly stupid and goes against all science. And I know recently, it seems that we are kind of Americans are anti-science right now, based off of how people have treated the pandemic. Okay, but like it goes against all science for you all to be starting school the earliest. Okay, you all shouldn't be high schoolers shouldn't be starting school until 8:30 or 9 o'clock probably. Who should be the ones who start at 7:15? Yeah, element adults. What? No. What do you mean adult? Like, okay, yeah, elementary school kids should be because they go to sleep at like 7 o'clock at night and they're awake this early. So why not just get them? Now I know why they do it because like parents work and whatnot, but it goes against all science. All right, and then Adults need about 7 to 8, right? And then elderly people only need about 5 to 6. As you get older, the less sleep you need. Like, I don't know if you've ever noticed it, like with your grandparents, but like they're like perfectly fine, like going to bed at like midnight and like waking up at like 5 o'clock in the morning, or they'll go to bed at like 8 o'clock and then they're like up and going at like 3:30, like just ready to go. All right, so let's talk about the stages of sleep. So we go through every night, we go through a series of what are called sleep stages. All right. And these stages, we go through about every 90 minutes. We cycle through 4 different stages of sleep. We know this because we can read brain waves. We can read people's brain waves using an EEG, an electroencephalogram. And during sleep studies, what they have found is that at different points of the night, our brain puts off different types of brain waves. And these different types of brain waves give an indication of what stage of sleep someone is in. So when we are awake and alert, our brain puts off what are called beta waves. Beta waves are high frequency, low amplitude waves that you see here. Okay, you just need to know beta waves, awake and alert. When we are awake but relaxed, when you are about to fall asleep, okay, our brain starts putting off a high amplitude wave, what are called alpha waves. Okay, so this is when they are about to fall asleep. And you can see right here, going from alpha waves to stage 1, what are called theta waves. So you can see there's the switch right there going from being awake to asleep. Okay? All right, so when we first fall asleep, all right, the first stage that we go into, we go from being awake to going into a very brief, only lasts for about 5 to 10 minutes, very brief and light stage, what is called NREM 1, non-REM 1, or just stage 1. In this stage, our breathing starts to slow. You know, that's how you can tell when somebody falls asleep, right? Breathing starts to slow, and we display these irregular brain waves, okay, what are called theta waves. Now, one of the main things, so in each one of these stages, guys, just like with like stages of development, there are certain things that you need to know that happen in each stage. Who in here has ever fallen asleep in class, right? You know, you put your head down in class, and you know how you've had this thing where you put your head down, you're kind of asleep, but you can still hear the teacher, but it's almost like you can hear them, but it doesn't make any sense. And you have like these like weird, it's like weird stuff going on. It's almost kind of like you're hallucinating a little bit. Yeah. Okay. One of the main things that they see in stage one are what are called hypnagogic sensations. Okay. Or hypnagogic hallucinations, which is similar to what lucid dreaming is. Okay. Now, how about who in here has you get falling asleep in class, you got your head down, you're like kind of falling asleep, and then all of a sudden you just kind of jerk up, all right, and you just like wake up really quickly, probably because it felt like you were falling. Has anybody ever had that before? Yes. Okay. That is a hypnagogic hallucination. All right. It's what's called a hypnic jerk. Now, how about when you're just like, maybe not that extreme, but when you're lying in bed, falling asleep, and you just kind of have these like random like jerking motions, like all of a sudden, like your leg will just twitch. Have you ever noticed that before? Yeah, that's a hypnic jerk. Okay. They don't really know why these happen. They think like the thing where you all of a sudden like jerk out of being asleep is because if you fall asleep really quickly like that, your brain thinks that you're dying and it tries to like pull you out of it. All right. But, you know, in this stage, we get these feelings of floating, we get these feelings of falling, we get these weird dreamlike hallucinations. I tend to see like a lot of like colors and whatnot, a lot of like vivid colors during it. But all of these are what are referred to as hypnagogic hypnagogic sensations or hypnagogic hallucinations. All right. Are there any questions there about stage one? So, like we said, it only lasts for about 5 to 10 minutes or so. Because in this stage, you are only lightly asleep. Like you can still, in this stage, your brain is partially asleep, but it can still like hear things that are going on outside of it. That's why when you fall asleep like this in class, you can still hear the teacher, but it's like your brain is not, it's processing it in a weird dreamlike manner. Oh, has anybody ever had the thing where you're falling asleep and all of a sudden you like hear like a loud like bang and it wakes you up really quickly? Anybody ever had that before? Okay. Anybody know what that's called? That's another hypnagogic thing. It's really weird. I've had it a few times. It's called exploding head syndrome. I don't know why it happens, but it usually wakes you up really fast. So is it possible that if you fell asleep in this stage in class, you would be able to retain some of the info? Possibly, yeah. All right. So after about 5 to 10 minutes, we go into NREM 2, all right, or stage 2. All right. NREM 2 lasts for about 20 minutes or so, but we actually we are in this stage longer throughout the night than any other stage. So you can see here we go from being awake to NREM 1 and then into NREM 2. The main thing that you need to remember about this stage is the presence of what are called sleep spindles, which are these bursts of activity. They also see these spikes right here. I don't think you'd be asked about this. I'm not going to ask you about it, but these spikes are what are called K complexes. And they are associated with outside stimuli. So, like being asleep, but hearing something on the outside. When you take a nap, so they tell you to that naps should not really last any longer than, no, this is not where you have the most dreams. Okay. They tell you that naps really shouldn't last longer than 20 to 45 minutes. That's because like a 20 to 30-minute nap is actually ideal for getting into stage 2. But if you go longer than that, then you get into deep sleep. Like if you take like a 45-minute nap, you're going to wake up while you're in deep sleep, which is going to make you feel groggy. A 20-minute nap, you're going to wake up after stage 2, all right, which is going to make you feel more refreshed. All right. Then from stage 2, we go into what is called NREM 3 or stage 3, which is deep sleep. Deep sleep, you can see how the waves have changed from these low amplitude, high frequency to high amplitude, low frequency. Okay. These, what you see in this stage are the presence of what are called delta waves. And this is easy to remember that delta waves are in deep sleep because delta and deep both start with a D. So you can see here, all right, we go from stage 2 and then we go into stage 3. Deep sleep is where we do most of our growing. It's necessary, but we actually get the most of it. We get most of our deep sleep early in the night. As the night goes on, we get less and less of it until as you're getting closer to waking up, we don't get any. You go back and forth from stage 2 to REM. Now, who in here, anybody in here sleepwalk or sleepwalk when you were younger? No one? I sleepwalk. I do this weird thing where I'll like partially wake up, but I'll still be like kind of asleep, and it'll be like 1:30 in the morning, and I'll just like hop out of bed and like think it's time to get up and take a shower, and then I'll be like I'll wake up kind of and be like, why am I so tired? And I'll look at it and be like 1:30 in the morning. Why do your brain waves when it regulate more senses? Harper, I don't understand what that question is. Why do they? Because this is called slow wave sleep. It's basically this type of sleep right here is slowing your brain down so that it can rest. Anybody in here sleep talk? No one? No one has any of these parasomnias? Used to? Okay, yep. I sleep talk. Did anybody have night terrors as a child? You probably don't have them anymore, but they're more common in male boys or male children. Okay, all right. All right. Anybody, what is a night terror? It's different than a nightmare. Anyone? Guys, the faster we answer questions, the faster I get you out of here. All right, well, even though people said they had them, you don't know what they are. Okay. Night terror is when We generally see it with little kids. No, as I said, they're different than nightmares. Okay. See them with little kids where they will look like they are awake. They'll be like sitting there in bed. Their eyes will be open. They'll look like they're awake. And they will generally give off this just like abject terror. Like they may just be sitting there being like, ah, 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 just like screaming. Okay. They are not awake. They are dead asleep. All right. They generally will not remember it the next day. Okay. And they are very, very hard to bring out of it. Okay. They don't really know why this happens. All right. But yeah, it's pretty common with little kids. We'll look at it again next class when we talk about sleep disorders. All right, but those are yeah. Why do some people sleepwalk, talk, while others don't? It's just why some people, everybody's different. I'm not entirely sure why. There might be maybe some people sleepwalking and sleep talking is generally associated with sleep deprivation as well, and so it's almost like when you're when you are so sleep deprived, your brain starts to do these weird things. Did anybody wet their bed? Okay. Yep. Okay. Yeah. My brother, he wet his bed until like the age of like 12, and he had to wear one of those things on his boxers where and wetting the bed happens because you're in such a deep sleep that you don't even wake up to go to the bathroom. But he had to wear like a buzzer on his boxers to it would start going off whenever he would start peeing in the middle of the night. Um, I'm sure Boo would be thrilled that I'm putting that out there. All right, so all of these things are things that are associated with stage 3, with deep sleep. Now, one of the things that I think confuses people the most in this unit is, so once we go through deep sleep, we're almost done, guys. Once we go through deep sleep, we then actually rapidly cycle back up through stage 2. It's like a roller coaster. Okay. It goes down into deep sleep and then it goes back up. So you can see once we go through deep sleep for about 30 minutes or so, we then very quickly go back into stage 2. But instead of going back into stage 1, we really only go into stage 1 if we wake up. All right. Instead of going through stage 1, we go into another stage of sleep that is very close to being awake, what is called REM sleep, or rapid eye movement. So basically it goes 1, 2, 3, 2, REM. REM sleep is called this because, has anybody ever watched somebody sleeping before? Somebody who's been asleep for like 45 minutes to an hour? Yeah. All right, creeps. Okay. Have you ever noticed, if you're watching somebody sleep, or even if you're watching like your dog sleep, okay, at a certain point when you're watching, under their eyelids, you'll be able to see their eyes moving back and forth really fast. Has anybody ever seen this before? Okay. If you have, all right, then that indicates that they are in, yeah, it looks like they're watching a tennis game. Yep. That indicates that they are in REM sleep. Now, as the night goes on, we get more and more REM sleep and less deep sleep. So REM sleep and deep sleep are negatively correlated. As REM sleep goes up, deep sleep goes down. What is interesting about REM sleep is the brain looks like it is awake, meaning the brain waves Like a tickle in my throat. Meaning the brain waves show the indication that the brain is awake, right? Hence, it is referred to as paradoxical sleep. Does anybody know what a paradox is? Anyone? It's hard to put into words, but yeah. Well, a paradox is two things that are contradictory of one another. Okay, so we are asleep in REM, but the brain looks like it is awake. REM sleep is where we do the majority of our vivid dreaming. And getting through REM sleep is when we can naturally wake up. You naturally, if it's in the morning, have you ever noticed if you're able to wake up on your own, like we generally wake up in the middle of a dream if we're not waking up from our alarm. That's because you can see REM sleep is the natural time for us to wake up. Now, there is a lot of motor cortex activity during this stage. There's a lot of brain activity, but we don't act out our dreams, okay? Because the brainstem blocks those motor signals. Does anybody remember what structure of the brainstem blocks those motor signals from traveling down to the rest of the body? I know it was a while ago, but what part of the brainstem blocks those motor signals? Not the medulla. The medulla is heartbeat. Yeah, the pons. The pons blocks those motor signals. Now, some get through. That's why we twitch a little bit when we're dreaming. Okay. You know, you see your dog acting like it's running, like it's probably dreaming about running. All right. But for the most part, a lot of those motor signals are blocked. Now, one of the other things that happens during this stage is males and females tend to have genital arousal during this stage, unless you're having a nightmare. Usually you don't have it, but even if you're having a non-sexual dream, we tend to have genital arousal. Now, I know at least for guys, like guys kind of, there's a term that, a slang term for this that, don't need to put out there, but I think most of the guys in here probably know what it is. All right, but it happens with for guys and girls. So we just kind of naturally have genital arousal. Part of it is so we also don't pee ourselves. All right. Especially with guys, it makes it so you don't pee yourself. Okay. All right. So once we go through REM sleep, we either wake up or we go back into stage 2. And so it's just a constant up and down all through the night until we wake up. All right. Does anybody have any questions there about those sleep stages? Why do some people, even if they get a necessary amount of sleep the night before, still sleep for a while if not woken up? Everybody needs a different amount of sleep. Yeah. So some of you can probably function perfectly fine on 5 to 6 hours. Some of y'all need 9 hours per night to function perfectly fine, to function normally. Okay. All right, guys.